IR. This is IL. This is IC. So according to Kirchhoff current law, total current IT equal to IR plus IL plus IL plus IC. IL plus IC. Then, according to from parallel circuit, we know that Y equivalent equal to Y1 plus Y2 plus Y3. Y1 plus Y2. Suppose Y1, Y2, Y3, so on Yn. Means different resistance are in parallel. Then admittance value equal to Y1 plus Y2 plus so on Y equal to in parallel circuit. Here this admittance. That we are considering this is resistance. Admittance means reciprocal of resistance is the admittance. Then here Y equal to, we know the formula, Y equal to G plus, last class what is G plus JB form. G is the conductance, B is the susceptance. G is the conductance, B is the susceptance. Then here Y equal to, see here from the circuit, reciprocal of all the parameters, then here 1 by 10. So in terms of value, then let we are considering this is R, this is L, this is C. 1 by R plus 1 by XL plus 1 by XC. That is equal to 1 by R plus 1 by XL means 1 by J omega L in terms of here. 1 by JXL. Then that is J omega here. In terms of here,
Hello, sir.
JXL here. Here also JX.
Sir.
Tell me, ma. చెప్పండి మా.
సార్ మీ వాయిస్ వినబడడం లేదు సార్.
మీ నెట్వర్క్ అన్‌స్టేబుల్
వాయిస్ వినబడడం లేదు సార్.
నెట్వర్క్ మీది ప్రాబ్లం ఉన్నట్టుంది మా. నాది ఓకే, క్లియర్ గానే ఉంది. ఒక్క నిమిషం. ఇప్పుడు వినపడుతుందా? వినపడుతుందమ్మా?
Yes sir.
J omega L here plus 1 by here J omega C here. J omega C here 1 by JXC here. So finally we have to see here. J omega L here 1 by 1 divided by JXC means then J omega C. And finally we'll get 1 by R plus 1 by J omega L (1 by j omega L plus j omega C. If you are seeing here, 1 by R is the same. In the both the terms, J is the common. In the both the terms, J is the common means J is the common. Omega C minus 1 by omega L. Why I am taking J common this and numerator lo, denominator lo J square aita. J square means 1 minus 1. J omega L. So we all know that at resonant condition, susceptance part equal to 0. That means B equal to 0. B equal to 0 means omega at resonant condition, omega L, omega C minus 1 by omega R L equal to 0. From this, omega R equal to 1 by root LC. So we know this is the formula for resonant frequency when resistance, inductance, capacitance are in parallel. So 1 by root LC. What is the value of L? L value at the problem law 200 milli Henry. 200 into 10 to the power of 200 milli Henry into C 5 farad. So then what is the value of here? 200 milli Henry, 200 into 10 to the power of minus 3, 5 farad. 5 into 200, 1000. 1000 into 10 to the power of 1. So what is the resonant frequency here? 1 Hz. Omega R value is 1 Hz. Omega R value is 1 Hz. So this is resonant, the angular resonant frequency. Omega R value equal to 1 Hz. This is the first question. Next question is bandwidth. So what is the formula for bandwidth? F2 minus F1. Bandwidth equal to F2 minus F1. That is equal to last class were derived parallel circuit for this case. Bandwidth equal to R by omega L. R by omega L or omega R into L. So what is the value of R? R value enta ba? 10. 10 divided by 1 into L value enta 200 milli Henry. 200 10 to the power of minus 3. So 0 cancel out. 1 by 20, 1000 by 20. Finally 1000 by 20 and what is the value? 50. 1000 by 20, 50 Hertz is the bandwidth. 50 Hertz is the bandwidth. Then what is the formula for quality factor? Quality factor Q equal to FR by bandwidth. FR by bandwidth. What is the value of FR? 1. Bandwidth is 50. 1 by 50. Approximately 0.02, right? 5 and 0.02. Huh?
Yes, sir.
approximately 0.02 is the quality factor. This is the way to calculate the resonance frequency, bandwidth and quality factor when resistance, inductance, capacitance are in parallel. So అర్థమైందా ఇది? Hello.
అర్థమైంది సార్.
Right, one more problem related to parallel resonance. ఇది నోట్ చేసుకున్నారమ్మా? నోట్ చేసుకున్నారా? అరే చేస్తాను.
ఒక నిమిషం.
నోట్ చేసుకున్నారా? హలో హలో.
ఎస్ సార్, నోట్ చేసుకున్నాం సార్.
ఓకే. So one more circuit. So this is the question. See here. So calculate the resonant frequency. Note down question. Calculate the resonant frequency, dynamic resistance, bandwidth. The question is calculate the resonant frequency. Calculate the resonant frequency, dynamic resistance and bandwidth. Dynamic resistance and bandwidth. Three calculate చేయాలి. Dynamic resistance, resonance and bandwidth. You see here.
Sir, question మళ్ళీ ఒకసారి చెప్పండి సార్.
Already I discussed this circuit. This is a tank circuit, right? Tank circuit కదా నాన్న? లాస్ట్ క్లాస్లో చెప్పాను, ట్యాంక్ సర్క్యూటే కదా అది. అవునా కదా? ఓకే, మీకు అదే ట్యాంక్ సర్క్యూట్ తెలియకున్న నో ప్రాబ్లం. దెన్ ఐ హావ్ టు డిరైవ్ ఫస్ట్ క్యాల్కులేట్ resonant frequency formula. So here, see here, our aim is to calculate admittance. Y equal to, these two are in series, right? Resistance and inductance are in series, right? అవునా కదా? Resistance, inductance are in series and parallel with capacitance. I am writing, so admittance equation kada 1 by R plus j omega L, 1 by R plus j omega L plus 1 by minus j by omega c. That means 1 by xc approximately, then 1 by j omega c, right? 1 by minus j omega c. After simplifying, finally after simplifying we'll get plus j omega c, right? Avuna kada? See here, r minus factorization, r minus j omega L divided by r square plus omega L factorization whole square plus j omega c. Simplify this j omega c. Then here in this case, real part terms in one part, one term, and an imaginary part in other term. Then we'll get r by r square plus
omega L square.
omega L whole square. Omega L, omega square or L square or omega square, omega L whole square, right? Plus both the terms, j is the common, omega c minus omega L divided by r square, sorry, r square plus omega L square. Here we all know that this is in the form of G plus JB form. G plus
Sir, ఈ స్టెప్ మళ్ళీ ఎక్స్ప్లెయిన్ చేయండి సార్.
right.
ఆ స్టెప్ మళ్ళీ ఒకసారి సార్.
R minus J factorization apply చేశారమ్మా. ఆ 1 by R plus J omega L factorization apply చేస్తే R minus J omega L divided by R plus J omega L into R minus J omega L. అప్పుడు ఏమవుతుంది? A minus B into A plus B. A square minus B square. We'll get R square.
దాని తర్వాత ఎక్స్ప్లెయిన్ చేయండి సార్. ఇది
ఇదిదా? ఇదేనా?
కాదు సార్, ఇది రేషనలైజింగ్ చేస్తారు కదా సార్.
So
explain చేయండి సార్.
Separate the real term and imaginary part, right?
Yes sir.
Real part r by r square plus omega L square. అప్పుడు ఏమవుతుంది? minus j omega L divided by r square plus omega L square plus j omega c. Both the terms j is the common. J common తీస్తే omega c minus omega L is not total bar divided by కాదు. Omega c minus omega L by r square plus omega L square. This is in the form of G plus JB form. G plus JB form. So what is the value of G? G equal to R by R square plus omega
L whole square.
Omega square L square or omega L whole square, right? G value.
Yes sir.
So conductance kada G ante conductance, reciprocal of resistance, that means dynamic resistance. Appo dynamic resistance equal to 1 by G. Dynamic resistance equal to, the first question, 1 by G. So means
Yes, sir.
R square plus omega
square. Yeah.
L square divided by R. This is the formula for dynamic resistance. Later we will calculate the dynamic resistance value. We know the first to calculate the omega. So at resonant condition, susceptance part equal to 0. Susceptance part equal to 0 means omega C minus omega L by R square plus omega L square equal to 0. Then after simplification, then directly writing formulae, you have to do the simplification. omega r equal to resonant frequency, omega equal to omega r. Resonant frequency omega r equal to omega r means not omega into r, omega r. Resonant frequency square root of 1 by LC. Already derived చేసాం last class లో tank circuit. 1 by LC r square by L square. R square by L square. Then simplify చేయండి, equal to చేసి r square by L square equal to jc omega r terms in one side, remaining terms in other side. Finally we'll get 1 by LC minus r square by L square square root. Then this is the formula for omega r. Then omega r equal to square root of 1 by LC. What is the value of L? 1 millihenry. 1 millihenry means 10 power minus 3. 10 power minus 3. 1 millihenry into C value 10 microfarad. 10 into 10 to the power of minus 6. Microfarad into minus 6 kada. Minus 6 minus, what is the value of r? 2. R square means 2 square. 2 square divided by L value 1 millihenry. 10 to the power of minus 3 whole square. Minus 3 whole square. After simplification, we'll get what is the value of omega r is so to calculate 9.73 into 10. Calculate చేసుకోండి. 9.73 into 10 to the power of 3 cube h. After simplification, this is the first question. Resonant frequency omega r value, then fr value calculate చేసుకోండి. Then fr value means 2 pi divided by 2 pi is the fr, right? Dynamic resistance same formula 1 by g or r square plus omega square L square. So r square, what is the value of r square? 2 square plus omega value, omega value is 9.73 into 10 to the power of 2. 10 to the power of 3. 9.73 into 10 to the power of cube whole square into L value 1 millihenry. 10 to the power of minus 3 square divided by r. R value ఎంత 2. ఇది dynamic resistance value. So approximately the value is 50 H. Sorry, 50 ohm. So simplify చేస్తే 50 ohm వస్తుంది. So 50 ohm. Next ఏం కనుక్కోవాలి? Bandwidth. So tank circuit ki bandwidth మనం derive చేసాం 1 by RC. Bandwidth equal to 1 by RC. Parallel circuit lo bandwidth derive chesam 1 by RC. So what is the value of 1? R value 2, C value is 10 microfarad. T is 10 into 10 microfarad. 10 into 10 to the power of 10 to the power of minus 6. Then approximately what is the value of bandwidth is 2 kilohertz. 2 kilohertz. 2 kilohertz. This is about bandwidth, dynamic resistance, resonant frequency for the given circuit. అర్థమైందా ఇదే? What I am doing here, not in this circuit. Suppose whatever the circuit in parallel, Then first to calculate the admittance, first to derive the expression for admittance. Then I have to separate the real part and imaginary part. For at resonant condition, imaginary part equal to 0. That means susceptance part equal to 0. Then from susceptance part equal to 0, from that you have to calculate the resonant frequency. That is omega. Derive the expression for omega. So not in this circuit, whatever the parallel circuit. After deriving the expression for omega, substitute the values, calculate omega. Then go for dynamic resistance. Dynamic resistance means real part value reverse is the dynamic resistance. Real part means here. Real part means here. Real part value reciprocal of real part is the dynamic resistance. Then bandwidth, we know that 1 by RC formula in parallel circuit. Substitute and calculate. R 1 by RC, or one more formula there here for calculating bandwidth, R by L also. R by L. That means R by omega L. So R by omega L. That is also one more important thing is there for calculating the bandwidth. So this is about related to problems related to parallel resonance. Okay, అర్థమైందా నీ ప్రాబ్లం? హలో, అర్థమైందా బాబు?
సార్ అర్థం.
హలో
సార్ అర్థమైంది సార్.
Okay, related to 2 or 3 problems, you can solve it and consult. Right, ma. Thank you, ma. Next class will discuss.
Thank you, sir.
Okay,
one more topic.
okay, sir.